Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concepts of derivatives. So we have to sketch the curve of the function, and the function is f of x equals 3 minus x over 2x plus 5. So the first step here is to find the discontinuities in this function. Now this function is a rational function, so the discontinuities in this function can exist in the form of poles or vertical asymptotes. Now in this rational function, there is no factor that's common to the numerator and the denominator, so that's why this function has no poles. Now we can do the analysis for vertical asymptote. Now for that we should set the denominator equal to 0 and solve for x. So we get 2x plus 5 equals 0, and now we should isolate x. So we should subtract 5 from both sides. So the 5's on the left side get cancelled out. So we get 2x equals -5. And now we can divide both sides by 2. So the 2's on the left side get cancelled out. So we get x equals -5 over 2. So this is the equation of the vertical asymptote in this rational function. Now we have to analyze the behavior of the curve on the left side and right side of this vertical asymptote. So for that we can use the limit. So limit x approaches -5 over 2 from the left side. So it's 3 minus x over 2x plus 5. Now we can evaluate this limit. Now to evaluate this limit, we have to use a test value for x, which is to the left side of -5 over 2, which is also -2.5, but close to -2.5, so like -2.6. So if we sub in x as -2.6, the numerator will become positive and the denominator will be a negative value, because 2 times -2.6 will be -5.2, and plus 5 will give us a negative result. So the overall value for this limit will be negative. Now we can apply the limit on the right side. So limit x approaches -5 over 2 from the right side. So 3 minus x over 2x plus 5. So for this limit, we can use the x value to the right side of -2.5. So for example, -2.4, and that will make the numerator positive and the denominator also positive. So the overall value for this limit will be positive. So based on these outcomes, we can write the end behavior around the vertical asymptote as x approaches -5 over 2 from the left side, y approaches -infinity. And as x approaches -5 over 2 from the right side, y approaches positive infinity. So there is a very important concept we need to understand and memorize about analyzing the behavior of the curve on both sides of a vertical asymptote. Now the next step is to find the intercept for this function. So let's start with x-intercept. So for x-intercept, we should sub in the function value as 0 and then solve for x. So now we can cross multiply the denominator. So 0 times 2x plus 5 will be equal to 0. Now we can isolate x by adding x to both sides. So the x's on the right side will get cancelled out and we are left with x equals 3. So this function has just one x-intercept and we can write it as an ordered pair as 3, 0. Now we can find the y-intercept for this. So for y-intercept, we should sub in x as 0. So in the numerator, we get 3 and in the denominator, we get 5. So the y-intercept can be written as an ordered pair as. So these are the intercepts for this rational function. Now the next step is to find the critical point. So for that, we need to find the derivative of this function. Now this function is a rational function, so we can use the quotient rule to find its derivative. So our first step will be, so prime of f at x equals the derivative of the numerator. So numerator is 3 minus x, so its derivative will be 0 minus 1 times the denominator 2x plus 5, then minus the numerator minus x times the derivative of the denominator, which will be 2 plus 0 over the square of the denominator. Now we can simplify this expression. So prime of f of x equals, so in the numerator 0 minus 1 is negative 1 and we can distribute the negative 1 into the parentheses 2x plus 5. So we'll get negative 2x, negative 5, and in the second part, so 2 plus 0 is 2 and we can distribute the 2 and the negative sign in the parentheses. So we'll get negative 6 and then plus 2x over the denominator 2x plus 5 squared. Now we can combine like terms in the numerator, so the 2x's get cancelled out, so we are left with prime of f at x equals negative 11 over 2x plus 5 squared. Now critical points are points at which the derivative is either equal to 0 or undefined. So we can set the left side equal to 0 to solve for x, so negative 11 over 2x plus 5 squared. Now if we cross multiply the denominator to the left side, so we'll get 0 equals negative 11. So that means there are no critical points for which prime of f at x is equal to 0. So no critical points for which so prime of f at x is equal to 0. Now critical points are also points where the derivative is undefined, so that means the denominator should be equal to 0. Now the denominator here is 2x plus 5 squared, so if we set the denominator expression equal to 0 and solve for x, we get x equals negative 5 over 2, which is the vertical asymptote that we found earlier. So that means we have already done the analysis for that part. So now the next step is to find the horizontal asymptote in this function. So for that, we'll have to modify the given function equation. So the function is f at x equals 3 minus x over 2x plus 5. Now the degree of the denominator in this function is 1. To find the horizontal asymptote, we first have to divide each term in this function by x raised to the degree of the denominator, which is x exponent 1, which is also just x. So that means we first have to divide each term in the function by x. Now we can simplify this expression. So 3 over x stays as it is and x over x becomes 1. And then 2x over x is just 2 plus 5 over x. Now we can apply the limit x approaches infinity. The limit now we can apply the limit. So we get 3 over. Now we know that 1 over infinity is equal to 0. So that means 3 over infinity will just be 3 times 0. So that will equal to 0 minus 1 over. And now we can simplify this expression as negative 1 over 2. So that means the horizontal asymptote is at y equals negative 1 over 2. Now we need to analyze whether the curve approaches the horizontal asymptote from above or below. So for that, we'll apply the limit to this function. For x approaches a big negative number and a big positive number, and then we'll see if the expression value is greater than negative half or below negative half. So let's start with the left side. So limit x approaches negative 100 and then 3 minus x over 2x plus 5. Now we can apply the limit. So 3 minus negative 100 over 2 times negative 100 plus 5. So in the numerator we get 103 and in the denominator we get negative 195. Now if we evaluate this fraction, so we get a value that's less than negative 1 over 2 or negative 0.5. So in this case we can conclude that the curve approaches horizontal asymptote from below. Now we can evaluate the limit on the right side. So limit x approaches positive 100, 3 minus x over 2x plus 5. So we can sub in x as 100. So in the numerator we get negative 97 and in the denominator we get 205, which is greater than negative 1 over 2. That means the curve approaches horizontal asymptote from above. Now we can use all of these results to sketch the function. So let's start with the vertical asymptote. The vertical asymptote is at -5/2 or -2.5. So let's assume it's somewhere here, -5/2. So we can show the vertical asymptote like this. Now the end behavior around the vertical asymptote. So on the left side of the vertical asymptote, the curve approaches -infinity. So that's in the downward direction. And to the right side, it goes up in the upward direction. Now the intercept. So the x-intercept is 3, 0. So maybe somewhere here. And then the y-intercept is 0, 3/5. So somewhere here, 3/5. Now the function has no critical points. And then the horizontal asymptote is at -half. So maybe somewhere here. So this point is -1/2. Now the end behavior for the horizontal asymptote. Now on the left side, the curve approaches the horizontal asymptote from below. So like this. And on the right side, the curve approaches the horizontal asymptote from above. So like this. And now we can join these end behaviors to get the sketch of the function. So on the left side, the curve will look something like this. And on the right side, we have to sketch the curve in a way that it passes through the intercept. Then here, and then it passes here. And then it ultimately goes along the horizontal asymptote. So this should be the curve of this function. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.